Welcome to Security Control from Authentication Perspective. So from authentication perspective, OCI provides Identity and Access Management or IAM services. IAM services basically enable you to control who can do what in your OCI account. So who can log in, and once they have logged in, what kind of operations they can perform. Now, each OCI resource, meaning compute, virtual cloud network, all kind of storage, and all the other resources have a unique ID assigned to it that is called Oracle Cloud ID or OCID. Now, IAM uses traditional identity concepts such as principals, users groups, and policies, and it also introduces a new feature called compartment. And we'll look at compartment in a little bit more detail, but as we had talked earlier, compartments provide you a way to isolate and organize the resources that you have deployed within your OCI account. So here's a high-level view of IAM and what it provides. So we have our tenancy, which is basically the cloud account. Within this tenancy, we'll create users. These users can be mapped to groups. And then we write IAM policies to allow groups to perform certain actions. Hence, the users in that group also get that policy. So for example, if we look at policy A, it's saying allow some group to manage all resources in compartment, and then provides a compartment name. So all resource basically indicates everything, all the OCI resources and all kind of operations that are allowed can be performed on that resource. Now compartment, as I mentioned, is a logical entity, and that helps you identify and organize resources. So for example, if there's company A that has 5 different departments, sales, finance, engineering, etc., they can create a compartment in OCI for each of these departments. Now, you write IAM policy such as this. So you will create 5 corresponding groups and you will map users to that group. And then you will write a policy such as this, restricting a group to perform operations on all resources, but only in a specific compartment. So compartment here is a keyword. In that case, users that have authorization to perform operations in compartment A cannot do anything in compartment B. Meaning, let's say they want to create a compute instance, they will be allowed to create a compute instance in compartment A and not in compartment B. So you can see how IAM policies and compartment combined together help isolate and organize resources. It also helps when you have to do certain audit. So in this case, you can run a script or a CLI command to find out all the resources running in a compartment. And if you need to delete them or perform other operation, you can perform those. So now let's dig a bit deeper on user authentication part. Now that authentication can be password based. It could be an API key or an auth token that is used by a service or a user. So to access OCI console, you generally use a username and password. So here we are looking at Oracle Cloud Infrastructure resources. Now these resources can be accessed if you are on OCI console through making REST API calls, or you can SSH into a compute instance, for example. Now you need an API signing key to access REST APIs, and these API calls are protected. In addition, only the customer have the private key that corresponds to the public API key that is stored in OCI console. So authentication is very strong. It's a 2048-bit RSA key pair that is used. So all API calls, as you can see, are protected with very strong encryption, and the method is very secure. In the case of SSH, when somebody wants to SSH into a compute instance, now again they have a public-private key pair. And this key pair is what is used to sign in or SSH into compute instance. This again is a 2048-bit RSA key pair and very, very strong encryption. The third option is OR tokens. Now, OR tokens are different than API keys because OR token provide authentication against uh, uh, resources in OCI or third-party APIs that do not support Oracle's cloud infrastructure's signature-based authentication. So services such as Autonomous Data Warehouse and ADP, if a user needs to access them, they need to generate auth token. And this auth token can be generated from OCI console itself. So in addition to the authentication mechanisms that we looked at earlier, Oracle Cloud Infrastructure also provides multi-factor authentication. And it's basically a method of authentication that requires a user to use more than one factor to verify a user's identity. So if multi-factor authentication is enabled for a specific OCI account, then first authentication would be user signing in with their password. And once they have signed in, they'll be required to authenticate themselves again using an app such as Oracle Mobile Authenticator or Google Authenticator. So this feature is available within OCI, and it can be enabled directly from OCI console. As we can see here, it's a simple point and click, and once it's enabled, every user that logs in will require more than one method to authenticate themselves. So we looked at user authentication and accessing resources in OCI. What about instances? For example, compute instances. For that, OCI provides a feature called instance principals. Previous to this feature, the credentials for a compute instance, for example, if it was interacting with object storage, will have to be rotated. With instance principal, this is done automatically. So no more administrator do not need to rotate these credentials. These are done, provisioned and rotated automatically for you. This is achieved through creating what we call a dynamic group. Dynamic group allows customers to group instances, compute instances, as instance principals. This is very similar to user groups. So instances belonging to an instance group can make API calls to other OCI resources. And the membership in a dynamic group is determined by a set of matching rules. So for example, all instances in finance compartment or all instances in sales compartment can be grouped together to form a dynamic group. So once the group is created, that is the first step. Second step is to actually create an IAM policy to allowing instances in a dynamic group to make calls to resources in OCI. So in this example, we have a policy called policy that is allowing certain dynamic group to perform certain actions, for example, manage and then resource type. So here you can have object storage family or some other resource across the tenancy. So in this case, we are allowing instances that belong to a specific dynamic group to perform actions across on object storage across the tenancy. So what other resources can instance principals can access? And here's an example: object storage, block storage, VCN, load balancer. So all of these can be authorized to make API calls with their credentials automatically rotated and provisioned and rotated within OCI. So we looked at authentication and mechanisms available. Users can sign into OCI console using their username password. We can enable multi-factor authentication for them. We have API keys. On top of that, we have tokens that can be used to work with resources or services that do not use traditional API calls. We also have compartments that help you isolate and manage resources across different departments within your company or within your tenancy or within your OCI account. And then finally, for instance authentication, we have instance principals. In the next lecture, we'll look at security control from authorization perspective.